Okay, cool. Good evening, everyone. Good afternoon. We're going to do a quick refresher on study units 1 to 5. So basically just going through a few questions so that you're comfortable with study units 1 to 5. But I'm going to start with study units 4 and 5. So that is the one that assignment 2 is about. So basically, I'm just going to look at nearly at one question each on discrete, binomial, Poisson, and then doing a quick refresher on the other study units as well. Okay, so the first one that I want to look at is discrete. So basically, and I think that is some of the questions we had on the chat in the last week as well. How do you identify what this distribution is? So basically, the easiest way to look at it is if it is binomial or Poisson, you will need to use the table. If it's not, they would give the table to you. So when they give a table to you, we have a discrete distribution. But the other way to look at it as well is that, and yeah, it's a bit different because in Poisson, in this binomial, you can also get 0, 1, 2, 3. But here we don't have a n and a x like in the distribution nearly of a binomial. So here we have 5 x's. We basically on each of them we have a probability. Okay, so you can't get in this situation this probability for a value like 0.5 or 1.5 or anything like that. Again, so that is why this is discrete, because it is a 0, 1, 2, 3, or 5. Okay, so then basically the other thing that I think the question was asked a lot as well is when we look at least, we look at that statement, we look at that statement. So again, we will need to look at that and see what we actually do. But again, I'll want to just show you how I would do this with a discrete. Yes, there is a question.
Hi, John. Hi,
Yes.
John. If the table is given, then it is discrete distribution.
Yes.
Okay.
Yes.
Okay. Thank you. Thank you.
See, if it's any of the other two, they need to tell you that as well. So they can't give you a table like this, and it won't be Poisson, because Poisson will be the lambda, and it might be binomial, but then they need to tell you that as well. So then they need to tell you there's a n value and a x value. Here they're not telling you that. Here they just say x. And I think that's also the difference. Does that make sense?
Yes, John. It does make
Okay,
sense. Thank you.
cool. Okay, so let's look at then the probability of at least 2. So at least 2, what does that mean again? So at least 2 means, so who wants to go for that?
Or more. So at least two or more.
Cool. Okay, so at least 2 means 2 or more. Okay, so it is that portion. So it's basically that plus that plus that plus that. And if I do that calculation, 0.324 plus 0.299 plus 0.138 plus 0.025, I get 0,786. Okay, 0,786, but I am looking for the correct one. Okay, so that one is incorrect. Okay. Then smaller or equal to 5. So smaller or equal to 5, what would I look at?
That's going to be 5 and less, so that's going to be everything from 0 up to 5.
Okay, so 5 and less, so it's everything. And everything we know must be equal to 1. So that is also
That is correct.
the incorrect one. So we're still not there yet. Okay, so then smaller or equal to 4, bigger than 2. Smaller or equal to 4, so it includes 4, but bigger than 2, so it excludes 2. So it is only 3 and 4. And if I add those two together, it is actually the correct one. Okay. Then we need to work out the mean, and we need to work out the variance but for that, let's just quickly I have actually, let's just cut that. I have actually copied what we need to do, so that because again it is a lengthy process. So if we need to do the mean, we basically need to say that times that plus 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 that times that. Okay, so we need to do those 5, what is it, 1, 2, 3, 4, 5, 6 multiplications, and we need to add everything together. Okay, and luckily we got to this point where we had that one wrong. So if you calculate the mean out, it gives you 3 or 2.397. Very easy again, if you look at that answer to think you have it nearly the same, but obviously then that one is incorrect. And then again, if we now need to work out the variance, it is also a lengthy process, because now you need to say 0 minus that mean that you got there to the power of 2 times that probability plus 1 minus 2.397 to the power of 2 times 0,175 plus, and then you need to do that for all of those. Then you need to remember, okay, here they're asking variance, so cool, the answer will be variance. If it was standard deviation, we again needed to take the square root of that. So to get the mean and the variance, it's not difficult, it's just a lengthy process. And then it's very easy to make a mistake in that lengthy process. So also in the exam, I would first look at your probabilities. For discrete, for binomial, for Poisson, I will first look at probabilities. before I need to work out anything. So that is just maybe in Poisson where we know the mean and the variance is equal to lambda, maybe that's different, but definitely for discrete and binomial, by all means, I would first do the probabilities before I do the mean or the variance. Okay, any questions on discrete before we move over to binomial? Okay, let's go to the next one. Okay, and so nowhere in this do they tell us it is binomial. So let's look at what's needed to identify it. So a home security has a reliability rate of 10%. Okay, so or it works or it doesn't. Okay, so that is nearly also it's a success or failure. So reliability basically shows to you if it's working or not. Then what they also have, they've got a sample for us, which the discrete didn't have, and then it has also the X. Okay, so again, the difference between the binomial and discrete is it's basically something happening or not. So then it has a sample linked to it, and it has a X linked to it as well. And nearly to that previous question of we could have actually had they could have given you this in a table, or they could have done that in a table with a 0.00 and a 0.00. But I haven't seen them do it like that. So, but if they want to, they probably can, but I haven't seen it. So for binomial and Poisson, you will basically need to use the table. So I've copied this table in with the n is equal to 9. It is the 0.1 table. So I just basically did a cut on the one piece, so we don't need to sit with that whole table. So basically in here again, they ask us which of the following statements is incorrect. Previous question was correct. So again, just how easy one can make a mistake again if the first one is maybe correct or not. So let's quickly see. X equal to 2. So X equal to 2 is exactly where it is 2. So X equal to 2 is 0.1722. See, now if we were still in the mindset of looking for the correct one, we would have said correct and we would have gone to the next question. But we are looking for the incorrect one. So it's correct, but we're not there yet. Looking at X smaller than 1. Okay, so if we say X smaller than 1, what are we going to look at in the table? What value are we looking for?
We will be looking
0.
at that one.
Cool. Okay, so X smaller than 1 is basically looking at 0. If it was X smaller or equal to 1, we would have included the value of 1 as well. So just smaller than 1, it's only 0, so it's 0.3874. Again, correct. Okay, so then the next one, x bigger than 4. So x bigger than 4, what would we look at in the table for x bigger than 4?
Basically 5, 6, and 7.
Okay, 5, 6, and 7. Okay, so then we see 5 and 6 together is 0,00009. So that is probably my incorrect one. Okay. So, but let's just look at 4 and 5 as well. So 5, I also just want to show you. So smaller or equal to 3. So if it is smaller or equal to 3, where would we look at? Okay, smaller or equal to 3.
0 to 3.
Cool, 0 to 3. Okay, so we can add all of them together, or we can say 1 minus this group. Nearly you're going to make the same number of calculations, so I would rather just add all of these together. That would have given me did I now make a mistake because I'm getting something different? Okay, I'm getting something different. What do you guys get if you add those
I get
together?
0.9116.
Okay, the same year.
Okay.
Okay,
So that might be incorrect also.
so the answers will be on the next slide, so we'll get to that now. The binomial coefficient, and I don't think you guys have done anything like that before. I don't know if there was something like that in your assignment. I don't think so, because this was from a few years ago. So let me show you what that is as well. So let's go to the answers. Okay, so let's just quickly see what was different here. Okay, so that value is different. Okay, see, so they used the wrong values for this one. Because the first one is correct, oh no. I see, so they used totally the wrong. Yeah. Okay, so this whole, they used totally the wrong values for that. Okay, I will update this for you with what it should be, because it is not those numbers, it should be those 4 numbers. Okay, so this in one of the previous trial exam papers was wrong as well. Okay, good that we are working through some of these. Okay, then what the binomial coefficient is, and you guys would have seen it in when I think there was in the week questions around for combinations and those kind of things as well. So basically it is 6 factorial. So it's that one. So the formula is basically n divided by, so that one is normally, if I remember, you can write it as the x, So that is n to x. Sometimes it is written as n to r. So there's a few ways that you can write that. So basically it is n factorial, then that 3 is or r or the x factorial, and then it is n minus r factorial or n minus x factorial. So basically what that means is at the top it is 6 times 5 times 4 times 3 times 2 times 1. That's what 6 factorial means. I'll get to the question now. When 3 factorial is basically 3 to 1, we first do the 6 minus 3, which again is 3, so it's 3 to 1 again. Yes, quickly, let's get to the question.
Sorry, John. In your formula there you wrote n minus r factorial and n minus x factorial. Shouldn't the factorial be outside the bracket? Because that's saying only the x and the r of factorials.
Oh, thank you. Okay, yeah, so it should be like that. So that you first,
Yeah, all good.
yes, cool. So then what we normally do is cancel it out. So before you multiply, they've multiplied it out, I normally first cancel it out, because what's at the top you can divide by at the bottom. 2 goes into 2 once, 2 goes into 4 twice, 3 goes into 3 once, 3 go into 6 twice. So 2 times 5 times 2, it is in the end 20. And you can also see they use the symbol of combination. So basically 6 combination of 3. So again, there was some chat on the WhatsApp this week about combinations and permutations. So it can be, and I think there was something in the assignment on that. So basically this is nearly referring back to that. But that is, again, if you look at what binomial distribution is, so this is nearly again saying, does it happen or doesn't it happen? And then if you repeat it, does it happen, doesn't happen again. So it's nearly saying you can group it 20 times with the different outcomes. That is nearly what this piece is saying. Okay, that is binomial. Again, if you look at how we identify it, you will have a success or failure rate that they talk about. Then you will have a sample, and you will have the X that you need to identify on the table. Okay, discrete was only a X. Here they talk about basically the sample X and the failure rate. Then if we go into Poisson, now suddenly lots of the time they actually tell you it's Poisson, but how we also look for that is you won't see that they're talking about sample. So sample will be, or the N will not be there. They will talk about X, and what they will talk about as well is a time will be linked to it. So here they talk about denote the number of times that a patrol car passes through the neighborhood during a nightly shift, during the day, during a certain period. So there will be a time connection to it as well. The interesting thing for me in this question was that normally I want to see the number in a number, and you now need to, I first looked at it and I'm like, I'm scanning it and where's the number? And then it's actually, okay, 3 times. And there they also talk about the per nightly shift. Okay, so we know that lambda is equal to 3. So if lambda is equal to 3, the mean is equal to 3. If the mean is equal to 3, the variance is equal to 3. So let's look at incorrect. So for this one, I would actually look at those two first. Variance equal to 3, correct. I'm looking for incorrect. Average equal to 3, correct. Okay, so mean is average. So the first one and the last one is correct. So unfortunately, we now need to go to the tables, but again, I've copied the table in. So let's look at, that starts at 0. Sorry, so I didn't copy in the 0 to whatever it will be. So 0, 1, 0, 1, 2, 3. Okay, so I first want to look at the easiest, which is always the equal. So x equal to 3, 0, 0,2240, 0, 0,2240, correct. Okay, so at least now only sitting with 2. So here we need to look at x bigger than 1. Okay, so what will we do for x bigger than 1?
That will be everything from 2 up until the end, but the easiest way to calculate it is by taking 1 minus the first 2. That will be 0 and 1.
Okay, awesome. So 1 minus the first 2. Great. Okay, so let's do that. So the first 2 is 0.0498 plus 0.1494, which is 0,1992. So 1 minus that, we get, or I get
0,8008. That's what I
cool.
get.
Awesome. The same here. So then that one is the incorrect one. Let's just check the other one. Smaller or equal to 2. What will that be? How would you calculate that?
I'll just add 0, 1, and 2. That will be the easiest.
Yes. Okay, so the first 3, we'll add that together, and then we do get 0,4232. So for that one, we will just add the first 3. So it is smaller or equal to 2. So we need to say 2, 1, and 0. Okay.
Sorry, John, can you explain
yes.
how you got the 880?
Okay, cool. No problem. So we need to work out what's the probability of x bigger than 1. So we need to add all of these together. But there's no ways I'm going to do that in the exam to also make a mistake. But we know that all of these needs to add to 1. All the probabilities needs to add to 1. So then it's easier to say 1 minus that first 2. And then
So you say 1 minus
yes.
brackets, that plus that, close bracket.
Yes.
Okay, cool. Because I might have done it wrong on my calculator here.
Oh, okay.
So you do the same answer though.
So what I also normally do is I would say 0.0498 plus 0.1494. So I would have gotten 0,1992. then I would just change the sign before that to make it negative and then say +1. Then
Yeah.
I would
Yeah,
get
I got the
this.
same answer now. Yeah, I
Okay,
made a
cool.
circuit error there. Yeah. My bad.
Awesome. Okay, so that nearly is discrete, binomial, and Poisson. And this is how difficult it can be. I think what puts one off is that in the exam you're so pressured, and now also in the assignments you're so pressured because you know it's one of the three, where it's like, which one? And then you work with the numbers, and maybe there's the same on, or if you use for one table or the other table, there's answers. So I can get the confusion specifically when it's time pressure as well. When you don't always have the time to read through everything, you're basically looking to nearly see where the answers are. Is that how the assignment was as well, or still is as it is open?
Sorry, I didn't catch that question. I was drifting there for
Oh,
a bit.
no,
Can you just
don't
repeat the
worry.
question?
Is this the type of questions they do ask in the assignment? And it's more for you guys to also understand the differences between the probability distribution functions.
I haven't started the assignment yet, to be honest.
Okay.
Yeah, they basically do test your knowledge on basically doing the binomial, discrete, and Poisson, but it's it's a lot more complicated than the examples we're doing, because not only are they testing your ability to be able to do the calculations, but they're also testing your theory based on binomial, Poisson, and discrete abilities.
Okay.
So it becomes a bit very challenging, if I have to put it that way.
Okay. So I think it's due on Monday. So the e-tutors will get the assignments or the questions on, I think, Wednesday or Thursday. Then I will set up some time that we work through both assignments, 1 and 2.
Yeah, for me personally, I felt like the binomial and the Poisson questions was actually a lot easier compared to the discrete one. So I think the first 8 is a bit challenging if you don't understand the theory behind how to
And
do it.
there was probably other probability questions in as well that you need to, maybe tables with mutually exclusive and those kind of things.
Yeah, that's the type of question they asked.
Okay. See, luckily in the exam, it is nearly 1 or 2 questions per chapter. So it's not that it's skewed to a certain chapter in your exam. So you will basically have, I think it is the first 5 chapters will be your first paper on, and again it is like 12 questions, and then the last 6 chapters will be about 13 questions. So that is normally how it is done, and then it is a spread over those study units. So it's not that one study unit suddenly have 6 questions on it and the others not. But I think the assignments are different. So the assignments are a bit, I think sometimes the more difficult questions comes in. Okay, so then let's first do this one on probability, as I think this was also in the assignment 2. So here they ask us, let's just get that. That's still fine. Okay. A group of 150 CEOs is tested for a personality type. The following table gives the results in the survey. So type A, type B, men, women, there's the total of 150. They say complete the missing values before calculating, but let's first look at the question. If one CEO is selected at random from a group, which one of the following statements is correct? So the event woman and type A personality is mutually exclusive. Yes or no?
That is incorrect because mutually exclusive means where the two intersects, the value should be 0.
Okay, awesome. So if there was a 0, then it would have been mutually exclusive.
This was actually one of my questions I had. That's why I know it.
Okay. Oh, serious?
Yep. Yes, it was one of my questions where they actually asked me, I can't remember the exact question, but it was exactly the same. And then they actually asked me to find the incorrect one. And then they actually stated that, for example, in this scenario, woman and type A is mutually exclusive. And that was my correct answer because it was incorrect.
Okay, cool. Okay. Okay, so this stuff does work.
Yes.
Okay, so that should have been 0 if it was mutually exclusive. So wait now. Okay, so that one is then not, so that one is wrong, eh?
That is, yeah.
Again, very easy to now make the mistake to say, is it mutually exclusive? No, it's not. And then is it correct? Okay, so let's look at the next one.
Jean, do you mind just completing the table just for practice?
Okay. Okay, this one is the easiest. That is 50. So it is 150 minus 120 to give me that. And this one is 53. So it is the 42 plus the 11.
Yeah, because when I was doing the practice questions, like I've got tricks sometimes, but I make sure that I do what they tell me to do. So if you think you don't need info, actually do need info.
Yes, and I think that is also what happens a lot is nearly with how you nearly complete it. I was hoping that the first one would be nearly the wrong one and I don't need to complete it, but I would have now completed it in any case to do this one. So what is the probability of men given type B? Sure.
Okay, so for that one, you will then take the 42 and divide it by the type B's total, which is 53.
Divided by 53. Okay, so the other way that we could have done it, and this is more how I sometimes remember it. If we have that, how I remember it is the probability of a and of a 2 that we are looking at. It's the probability of the M and the B. So that is the probability of the M and the B. So that is the 42 divided by the second one. The
which is probability of B. Yeah.
Probability of B, which is the 53. Cool. Okay, so that would also be incorrect because that will be something like must be somewhere in the 80s. So it is, what is it, 42 divided by 53, 0.7925. Just want to check if I had the answer set somewhere or not. No, I didn't. Okay, so I'll copy that in at a later stage as well for you guys. Okay, probability of V and B. Probability of women and B. So it is 11, but 11 divided by what?
The total, which will be the total events of both the genders and the types, which will be then 150.
Cool. And that will then actually be equal to 0.073, which option 3 is the correct one. Okay, probability of women is 30 divided by, so it's the probability of a woman, 30 divided by the total, so it is 30 divided by 150. 3 divided, what is that, a third, I think. Oh, 20. 20%, so 0.2. Let me just check that again. Yes. Okay, so that one would have been wrong as well. Probability of, okay, this now is interesting. So probability of B given M, so nearly that swapped around. So what's the probability of B given M? So again, we will have the M and B, so that will still be the 42. But now instead of dividing by 53, we divide by 120. So that will probably be then the 0.35. Yes. So basically, if you swapped that and that around, you would have gotten that correct and you would have gotten that correct, because that is basically just worked out the other way. Okay, so that is looking quickly at probability. There was some of the missing numbers that we completed. Need to remember the mutual exclusive rule, and then basically what is when something is given, how do you calculate that? Yes, there was a question, or has it been answered?
Sorry, quick one. At point number 3, we said 11 divided by 150.
Yes.
How did we come to dividing by 150, please?
Okay, so when, and nearly you can look at it with option or question, the option 4 as well. When they don't tell us given something, we assume it is the full sample of 150. So here they just ask us what's the probability of that happening. So we don't know if it is given type or given gender, so then we assume it is the total sample, and that's why we divide by the total of 150. The same with question 4, but what's the probability of women? So it is basically the 30 divided by the 150. Okay, Tembi, yes, please ask.
Okay, I'm not sure about number 5, the last one, because it's B and M. I thought the 120 is for only M.
Okay,
So I would have said 42 divided by 150, so I don't understand it.
Okay, so it's It is what is the probability that you type B given that you are a man? So given that you are a man is 120. That's why we divide by 120. If it was only the probability of B, then we would have taken away the M and divided by 150. But because they're telling us basically what's the probability that you are type B when you are a man.
Okay.
So nearly we need to, when you look at the given, it basically tells you you are. So with a question 2, so you are type B, what's the probability that you are a man as well? Question 5 was you are a man, what is the probability that you type B as well? Okay, so that nearly every time when it is given, it is nearly, okay, so you are only looking at the given part. Okay.
Okay.
Cool. Then I've got a few minutes before I am going into load shedding at 6 again. So let's.
So, there was one question I actually wanted to ask
Cool.
with the previous table, and I'm actually not sure if I'm allowed to do it because it's actually the same as one of the assignment questions. Is actually they would ask you something like the events, for example, the events type A and the events men. They would be are they independent or dependent? Those are also some of the type of questions they
Yes.
ask.
So what they normally ask is the mutually exclusive and the dependency. So the dependency one is where they will tell you that say A and B was equal to a value, and then they say like in option, so they could have said the event woman and type A is dependent. Then you would need to check. So, and the way you check it is to say, remember for dependency, we assume, so here, let's say type A times the men, that must be equal to the and, so A and B, or A and M. So if you say type A times type B, or sorry, type A times M, the probability of M, it should give you basically what is the and. If it is not, then it is not depend, or when it is, which one is it again? It's independent when the two are equal, not dependent when the two are not equal.
That's correct. Those are one of the questions also,
So,
like the type of questions they ask.
So that is basically how I would, you can get the independence with a mutually exclusive in one question, and that is normally how it would be in the exam, as you will only have nearly 1 or 2 questions on this probability. So then they will throw nearly everything into one question. So in the exam, you're much more likely to get one of the options is dependent or not. One of the options is mutually exclusive or not. One of the options is a normal. One of the options is the and one of the options is the given. Then you cover that, actually that whole study unit in one question. So where it is now nearly split over 3 or 4 questions in the exam, this whole study unit can be basically into one question.
That's actually one of the questions I got, if I remember correctly. I had all of them in one.
Yes, and that is nearly how it, that question would be how it would be in the exam as well.
Sweet.
Okay. Okay, let's quickly check. Just so this is going way back to your assignment 1, but since that is also still due for Monday, I thought let's quickly look at some of those as well. So given the following variables: marital status, household size, traveler's height, number of students, ethnicity, which one represents a qualitative variable?
Ethnicity.
Anything else? Okay, so number of students, no. Traveler's height, no.
Number one, or letter A.
Number
Yes or no? Yeah.
A.
Awesome. So marital status, ethnicity, so A and E, correct. Okay. So household size will be 1, 2, 3, 4, 5. Traveler's height will be in centimeters, meters, or whatever. Number of students, again, 1, 2, 3, 4. So all of that is quantitative variables. The only two that is qualitative is A and E. So how I would do it as well, when I look at it in the exam or in your assignments, I would look at A and I would say, okay, marital status. So I would say, okay, that is correct, that's wrong, that's correct, that's correct, that's wrong. Then I would go to the next one, household size. No, definitely B is wrong. So then I know that one is also wrong. Then I would say traveler's height. Okay, no, C is also wrong. So there's C, that's wrong. There's C, that's wrong. So even before I get to the bottom, I nearly know that that is the correct one. Okay, so let's look at another one. Which of the following statements is incorrect? The time it takes to read a book is a discrete variable. The parameter, see now they, okay, there's a bit of a, now they throw in, what was the study unit 2? Parameter is a characteristic measure of a population. Statistic as is a characteristic measure of a sample. Okay, that is correct. That is correct. So how I like to look at this is parameter, population, statistic, sample. So the two S's, the two P's, both is correct. This one is, I'm going to give a question mark there. When a distribution is symmetrical, the value of a mean, the value of a median, and the value of a mode are all equal, correct. The marks achieved by students in the final examination presents a continuous variable, correct. Okay, so, and remember here why it's continuous. It's because it is the percentage. So 11 divided by 25 or 10 divided by 25 or something like that. So it is not the 1, 2, 3, 4, 5. But discrete is also continuous, or otherwise it would have been discrete. So that is why this one is continuous, because it's not talking about you got a 1 or 2 correct or 3 correct. It is the mark. When we look at the time it takes to read a book, if I told us the time it takes to read a book in hours, then it would have been discrete, because then hours is 1, 2, 3, 4, 5, or 6 hours. But here they don't tell us that it is in hours, so we don't know what the length is. So it can include seconds, it can include days. So basically you don't know. So then it is a continuous variable, and that is why that one is incorrect. So this one was nearly a tricky one as well, because we normally associate, you would say, it took me 5 hours to get through this book. But they don't say it in the question. So they just tell you time. Okay, and if they don't say it, it's hours, then we assume time is a continuous variable. Okay, so this one was a bit a tricky one. Questions on that? Otherwise, we can go.
Nothing from me, John. Thank you.
Cool. We can go to the next one. So again, let's quickly look at this, the incorrect one. And I nearly look at that unordered 2830. So that for me is already, okay, that's the wrong one, because that's ordered data. Can it be that easy that we don't need to work out all of the others? Okay, so that is for ordered data and not unordered. So option 5 is incorrect, but I'm going to use this to nearly answer some of the other ones. So let's look at the mode. There's 240, so the mode is 40. How many? So there's 10. So to get the middle one, 1, 2, 3, 4, 1, 2, 3, 4. So the middle value is those, in between those two. So in between 35 and 37 is 36. So what we could have also done is to say 35 plus 37 divided by 2 will also give us the 36. So the median is also correct. The sample, you basically need to add all of that and divide by 10. And I think I did it in the next one. So the sample is 37.8. Interesting here, that should have been incorrect, eh? So the sample is, and then the distribution tails to the right. So how we can look at that is nearly to look at that. How I normally do this is to write it down. But so there's not a 29, so there's a 30. There's not a 51, 52, so there's a 53. So I'm nearly writing it on a timeline to see if I can get anything out of it. There's a 35, there's a gap, then it's 37, then there's a few gaps, 40, 40, a 43, and a 45. And if you look at that, it's going to look something like that. So tails to the right, it's probably tailing to the left. Okay, so distribution tails to the right if the value of a mean is greater than the median. Okay, so it actually tails to the right. Okay, that is interesting. So let me take that out. So basically here you need to follow the rules. And I think I have written that down also on my notes. So I will just go to my notes again for this one.
Sean, can you just repeat what you said? The data tails right if the mean is greater than the mode.
I just wanted the distribution
sorry, the median.
Tails to the right if the value of a mean is greater than the median. So we know that the value of a mean is greater than the median. Tails to the right. I will just check that, but I'll go and check my notes because I know I've written those free down on the notes. But definitely option 5 is incorrect because that is audit data. Okay, last one, and let's see if I still have a minute or two. The following is a stem and leaf. Which one of the following statements is incorrect? The range is 52. So the range we'll get by taking the maximum, which is 73 minus 41. 73 minus 41 is 52. So that is correct. The mode, so there can be 2 modes. So let's just 52, there's 2 of them, 2 of 62, 2 of 63. So there's actually 3 modes. So 52 is also a mode. So 52 is also a mode. So that one is incorrect. So that at least we know. The fifth largest, we basically start at the top and count back. So biggest, second largest, third, fourth, fifth largest is 66, which is correct. Median is 17 cars, so the median is your 9th one, because when there's 8 on the one side, 8 to the other side, and your 9th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 61, so your median is, the mean is the measure that is affected by the outlier. So if here was a value of, say, 91, the measure that it will affect, so the mode would not have changed, so it wouldn't have affected the mode. The mode would have still stayed 52, 65, 66. If that was 91 instead of 73, your median still would have been 61. So it wouldn't have impacted your median, but it would impact your mean, because your mean is a sum of everything. So because it impacts the mean, this one is also correct. Okay, so that is nearly looking at the stem and leaf, asking a few of the basic mean, median, and mode, but also throwing in a bit of theory in it as well. Okay, are you guys happy with this one as well?
Yes, thank you.
Okay.
Yes, we are.
Okay, so that is it, guys.
Yeah, thanks, Sean. Thank you very much.
So I will put this back onto, I'm hoping to put it on YouTube as well tonight or early tomorrow morning, that you can also just look at those probability and those things again to help you with preparation for the assignment. Okay, great, everyone. Have a good weekend and good luck with all the load shedding.
Thanks, Eugene.
They just said now load shedding suspended.
Thanks, Jane.
What?
Yeah. My power just went back on now, so.
Okay.
Then mine should be on as well. Oh.
Okay.
Yeah.
Okay.
All
Okay.
right. Cheers, guys.
Cheers, everyone.
Cheers.
Cheers.
Bye.
Cheers. Bye.